Okay, so we are going to factor out the greatest common factor of a polynomial. We've added and subtracted them. We've multiplied them. Now we need to talk about how to factor out a GCF, which I guess kind of is as close to dividing as we're going to get. So let's talk about two things. Let's go back to, I don't know, 3rd grade, 4th grade maybe, where we talked about the greatest common factor. So you need to know what a factor is first. So like, for example, if I were to say, list all the factors of 12, that's when your teacher had you do this. 1 times 12. My lights just went out. 2 times 6. 3 times 4. Okay? Those are the factors of 12. If I gave you 12 and 18 and asked you to find the GCF of those two numbers, all you do is find the factors of both of them. And then, I know you remember doing this, and then your teacher said, well, they both have a 1 in common, they both have a 2 in common, they both have a 3 in common, but the biggest one is 6. So that is a reminder on how to do GCF, okay? I'm counting on the fact that that comes pretty quickly back to you, okay? In algebra, that's with numbers. This is the GCF of numbers. Now we're going to find the GCF of exponents and variables, okay? So if I were to say, find the greatest common factor of x to the 2nd and x to the 5th, okay? That means like the greatest common factor is the biggest number that they both can give me, right? The biggest number that they both can give me from 12 and 18 is 6. So if I kind of write that x squared out in standard form and say there's 2 there and there's 5 here, what's the greatest number of x's that I can get from both of these monomials? 2, right? So the GCF of x to the 2nd and x to the 5th is x to the 2nd. I know I can get 5 x's out of here, but I can only get 2 out of here. So the GCF is always going to be your smallest exponent, okay? Keep that in mind. That's going to come in really handy, okay? So, so now that you know the GCF of that, that is just finding the GCF. So I'm not asking you to find the GCF. I'm asking you to factor out a GCF. So now that we know how to find it, let's talk about what it means to factor it out. So if I were to take and say 3x minus 30 and ask you to factor that. This is something we may have done in 7th grade. I can't remember. If I were to ask you, what is the GCF of this, the greatest common factor of a 3x and a 30, you would say 3, right? Okay? Here's what factoring out is. It is the distributive property in reverse order. It's basically saying, oh, I can factor out a 3. Oh, factoring out a 3 just means divide each of these terms by 3, right? But a lot of kids don't really like looking at it as division. They like looking at it as, oh, okay, if I'm going to factor out a 3 from this expression, what would I need to multiply 3 by? What would need to be right in that space that when I multiplied it by 3, I would get a 3x? Well, an x has got to go there, right? What would I need to multiply 3 by to get a negative 30? A negative 10, right? So I just factored this binomial, 3x minus 30, factored into a 3 times an x minus 10. Let's do another one. Let's do 15a or 15x minus 20. Okay? The greatest common factor of 15 and 20 is 5. And factoring it out, so I found the GCF, now factor it out, meaning what's left. So what would I need to multiply 5 by to get 15x? A 3 and an x, right? What would I need to multiply 5 by to get a negative 20? A negative 4, okay? So now let's go over to the algebraic side and see what that looks like for our exponents. If I asked you to find, like say x squared plus x to the 5th. All right, you told me that the GCF of that is x squared. Right, you found it, now factor it out, meaning what's left. And this is why it was really important that you learn those exponent properties in Unit 6, right? I know some of you were like so done with Unit 6, but that's what happens in math. You learn it because you need it later. So what would I multiply x to the 2nd by to get an x to the 2nd? It's times 1, right? What would I need to multiply an x to the second by to get an x to the fifth? That's the first exponent rule we learned. And when you know that when you're multiplying, you keep the base and you add the exponent. So what plus 2 gives you 5, right? Guys, that's all it is. Okay? So I factor that out. So what I want to do, let's take the GCF of a to the 7th minus a to the 4th. The biggest amount that they both can give me is an a to the 4th, which means I would have an a to the 3rd here because 4 plus 3 has to give me 7 minus 1, correct? Find it, factor it out, okay? So now what I want to do is take these two, the 4th and 5th grade part of it, the algebra part of it, and put it together, okay? So let's see what that looks like. That looks like this. Let's say 5x squared minus 45x, okay? And seriously, you can treat this as two separate problems. You can just look at the numbers and say, well, what's the GCF of 5 and 45? 5, okay? But they both have some x's that they could give me. I can get 2 out of this one, but only 1 out of this one. So the GCF can only be an x. 5x, got it? So really what I'm doing is just dividing each of these by 5x, or looking at it as, what would I need to multiply 5x by to get 5x squared? I have 1x, but I need 2, so there's my other one, right? Because 1 plus 1 is 2. 5 times 9 is 45. Make sure it's a negative, okay? All right. Let's do one more of this. Let's say 24a squared b to the 3rd plus 32ab to the 4th. All right. So we got literally 3 problems in one here. Find the GCF of the numbers. Find the GCF of the A's, find the GCF of the B's, and then pull them all out. So the GCF of 24 and 32, it's bigger than 2, it's bigger than 4, 8 goes into each of these. So I'm going to take an 8 out. How many and what is the most number of A's that you can give me? This has 2, but this only has 1. This has 3, and this has 4. So my GCF is 8ab cubed. What would I need to multiply? And here's how you can picture it. 8ab cubed times what will give me 24a squared b cubed. So I have to multiply the 8 times the 3. I have 1a, but I need 2, so I need to put another one there. And I have enough b's, so I don't put any b's. Because if I put a b, that would mean it would be 4, and I don't have 4. Okay? And so then this is going to be plus 4. I have an a out. That's all I need, so I don't put an a. I have 3 b's, but I need 1 more. Okay, I want you to just kind of look at that for a minute and see if that makes sense. I also want to show you something that you should notice in all of the ones that we've done. All of what's left in the parentheses should not have any more in it. Let's take this problem, 24, let's just keep it simple, 24a squared plus 32a. Let's say you didn't realize that there was an 8 in both of these, and you just took out a 4 and an a. Okay? No, let's say you even forgot to take out the a. Let's just say you thought GCF was 4. I'm doing this wrong on purpose. So if you did this, you would get a 6a squared, and then you would have your plus 8 and then a. When you look at your answer cannot have any more GCFs. There's another 2 in there. There's another a in there. So when you're done, the parentheses that's left, the GCF of that has to equal 1, meaning it can't have anything else in common but 1. There's a 2 still and there's an a still. So that tells you that was not the GCF. Got it? So that's a good way to do that. Okay, and then I want to show you one more thing, and it's really important setting you up for the next couple sections, 7.4 and 7.5. If your leading coefficient, you know that standard form of a polynomial is highest exponent down to lowest. So if I have negative 2x to the third plus 8x squared minus 10x plus 12, okay? The leading coefficient, which is kind of like the little line leader, right? It's not this is the caboose, this is the line leader, cannot be negative. No negatives. So you know what that means? In addition to factoring out just a regular common factor, like here we pulled out a 5, here we pulled out a 5, you have to pull out the negative. I need the highest exponent to be negative. So in addition to pulling out a 2, I'm pulling out that negative 2. Because, and by the way, I know I can't pull out any x's, right? How do I know? Because this doesn't have an x. I know this has 3 and this has 2 and this has 1, but that doesn't have any, and they all have to give me the same amount, right? So if your leading coefficient, which is your highest exponent coefficient, is a negative, pull it out too. Now, that's a little bit of a game changer. It changes things up a bit. Because if you look at it this way, what would I need to multiply? Well, you know you pull the negative out. So this is just going to be x cubed, right? This sign cannot just get brought down. You can't just bring down that plus as a plus. Because if, and I'll put it in pencil, if I were to put a plus 4x squared there, if I were to go back and check myself, that negative 2 times that positive would mean that's a negative. So here's the deal when you factor out a negative. Everything changes. The signs have to change. This negative positive is now a negative. This negative is now a positive. And this positive is now a negative. Okay? So when a negative comes out, you have to change all the signs. If you don't, you will be screwed up later in 7-5 when you try to factor. Okay? Another thing to keep in mind is this. If you want to know if you factored out the GCF correctly, all you have to do is check yourself by distributing back in. Is this times this that? Yep. Is negative 2 times negative 4x squared that? Is this times this that? And negative 2 times negative 6 is 12. Literally, you can get 100% on this assessment if you just factor or multiply your answers back in by using the distributive property.